Hey guys, Chef Andrea with Q&A with Chef A. This pod series, we've been talking about heat. We talked a little bit about heat as energy, thermal energy, what it does. We've talked a little bit about your own home oven, just kind of getting to know her a little bit better. Treat it with a little bit of love and it will love you back. And now that we know a little bit about heat as in thermal energy, we've run through some troubleshooting on our own ovens, how they work and what that preheat setting really looks like. What I want to talk about is something I get a lot of questions about, and that is convection. Okay, so first thing let's just talk about what convection is. And I'm going to tell you what it is in the form of a home oven. Convection in a home oven is a fan. That's it. In your home oven, when we're talking about convection, what we're talking about is having engaged a fan in your oven while it's heating. Why would we do it? All right, well, if you've done the last two videos with us, you know a little bit about heat and the concept that heat is always in motion. It is energy. Energy is always in motion. Heat's natural trajectory is either upwards, which it loves, or towards anything else that's cool. It always wants to morph and make everything else around it its same temperature. That's what it does. So we talked about this little 3D box, right? Here is an oven. This is the heating element, whatever that may be for you. It could be a couple of pilot lights, gas. It can be electric coil like mine. Heating element, typically in the bottom of an oven. It can be in the top as well. When I turn on the oven, this gets hot. That energy, heat is energy, transfers to the rest of the oven and gets the rest of the box hot. When I go with convection, an interesting thing happens. I turn a fan on, and usually the fan is either on the side or on the top. And what happens when I turn the fan on is that it literally takes the drifting energy. I'll draw some drifting energy. So energy is drifting upwards, and then once it gets upwards, it curls back down. So energy is drifting up, because heat always moves up. But once this upward area is whatever temperature this coil is, so let's say we set this at 350, now the top of the oven's 350, it needs some place to go, and what it's going to look for if it doesn't need to go up or heat anything here is it's going to look for cool. So it's going to drift back down and find some cool spots to start warming back up. So these will come up and drift off into this back corner, front corner, back corner, front corner. What happens when I turn a fan on, my convection oven here, the fan's on the side, is that it just blows that energy into every conceivable nook and cranny of this box. So a fan's blowing, and it's just taking all that thermal energy and just whooshing it. You're going into that corner, you're going into that corner, you're going into that corner. So it makes this really efficient movement of this thermal energy. Convection, a fan that creates very efficient movement of thermal energy. That's a pretty simple concept to grasp, isn't it? So as we talked about with this box, we said, one of the things about heat is that, let's say the coil's at the bottom and it's drifting upward. It may not be connecting with this back left corner or the front right corner of that box. And when that happens, heat kind of pools into certain areas. That's why you have two cookie sheets of chocolate chip cookies and you had to pull them both out and rotate them, or you had to pull them out and rotate them and put them back in because you're trying to capture those kind of hot spots in the oven. One thing that's nice about a convection, about a fan blowing, is it's blowing that thermal energy into every single one of those corners, nooks, and crannies, so you end up with very, very, very even heat all the way through, which is very efficient. If I'm cooking chocolate chip cookies and this tray is sitting in a cool spot, I either need to rotate it or move it, but this tray, for whatever reason, heat's getting trapped in this corner, is done 4 minutes faster, right? And so that's why the constant rotation. So there's an efficiency if both of them are just getting blasted with the right temperature for the entire bake time. So that's what convection does. It just moves thermal energy through to every nook and cranny. And if the heat isn't responsible for heating up here, then drifting back there, then coming back and getting this heated up again, oh, this has gotten cool, so I'm going to travel over there. Ah, that's cool now. I'm over this way. If heat doesn't doesn't have to do that work. A fan's blowing and just pushing heat all over the place. It is more efficient, and therefore, even at the same temperature, 350 is 350, something might take a few minutes less time to cook because it's such an efficient transfer of heat. Now, that's where we can get confused very easily. When I turned on my convection, I burned my tuna casserole. Convection is too hot for me. Nope. It's not about temperature. It's about efficiency, okay? I'm going to clarify that again. I've tried to bake a tuna casserole on convection, and it burnt. My tuna casserole takes 30 minutes at 350. I've been baking it for 20 years. But the first time I did 350 for 30 minutes in my convection, it was burnt at 30 minutes. So convection clearly is hotter. Nope, it's more efficient. And it means that that tuna casserole was probably done at minute 24 instead of minute 30. But it wasn't hotter. And here's what I want you to consider about heat and temperature. The way that temperature works for us, the science of it is simple. 350 degrees is 350 degrees. If I'm wearing a red shirt, it's still 350 degrees. If I'm standing in Alaska, it's still 350 degrees. If I'm on the South Pole, it's still 350 degrees. If I'm in Arizona, it's still 350 degrees. 350 is 350 no matter what else is happening to the exterior world. Hair up, hair down, it's 350. Why did the casserole burn at 350 on convection? Because the air that is convection, the fan that is convection, caused that box not to have cool spots, not to have drift where the heat was trying to move from one area to another. It became more efficient, not hotter. And that's a big difference. Let me give you an example of where we can have some trouble with that. Okay. One thing I want to cover very quickly is if you have a convection element on your range that you haven't used, I highly recommend you try it. But keep that in mind, that it's going to be more efficient. So if you're going to try it for cookies that always bake for 16 minutes, check them at minute 12. Check them again at minute 14. I bet you'll shave a little bit of cook time off of there just by going convection. It's not hotter. Okay, wait a minute, chef. I have a convection oven, and I know for a fact that when I set it at 350, it drops the temperature to 325 so that I don't burn what's in the oven. And it does that, chef, because 350 on convection is too hot. Nope. It does that, home baker, because it's afraid that you're not going to calculate for the efficiency, and so it dumbs the temperature down by 25 degrees so that you don't burn your cookies. Now you're on convection, you think you're 350, it's pulled it back to 325, so it still takes 16 minutes to bake a chocolate chip cookie. Had you done it at 350 on convection, it might have taken 12. But if you didn't know that and left it in for the full 16, they would have burned, and you would have liked to blame the oven for being too hot. It's not too hot. It's more efficient. 350 can't be anything but 350, whether there's a fan blowing or not, okay? If your oven is one of those ovens that dumbs down the temperature 25 degrees, I say be smarter than your oven. If you want to bake 12-minute cookies, you keep that temperature what you want it to be, which means what? That's right. You're going to have to go from 350 to 375 to engage the convection, knowing that your range is going to pull it back to 350 once you engage that fan, okay? You can be smarter than the manufacturer of your oven thinks that you can be, and you can take advantage of that efficiency. Here's where this can really work against you and probably has scared some people away from convection. I send you with a recipe that absolutely needs 400 degrees to work appropriately. It must be at least 400. In fact, I might have told you 425 is even better. But you decide that you're going to do this on convection. And so you decide that because convection is hotter, you're going to go 375 to my 400. And your convection oven decided to be smarter than you. And when you set it at 375 convection, it dropped it 25 more degrees. And now here you are at 350 trying to do something that I told you will only work at 400 to 425. You see how that can really start to work against you? Read your owner's manual, find out what it's doing on convection, and be smarter than it. You will not cut your cook time in half. In a 30-minute cook, you'll probably shave 6 to 4 minutes. I don't know what percentage that is. 1/16? I have no idea. But you're not going to cut it in half. A 30-minute cook time won't be 15 minutes on convection. It's not that efficient. But 4 to 6 minutes, that's pretty efficient. If you have an oven that has convection bake and convection roast, okay, guess what is happening with that? Convection bake dumbs it down 25 degrees when you engage convection. Convection roast doesn't. So now you've decided you're going to do something at 400 degrees on convection, but you go convection bake. It will drop at 25 degrees. Now you're at 375. That's a problem if what you're doing needs 400 degrees to make it happen, because 375 just isn't 400. Even an efficient fan-blown 375 is still not 400 degrees. If you need to be 400 and you engage the convection on convection roast, you are, in fact, at 400 degrees. And at 400 degrees with a fan engaged, you will get a much more efficient cook this time. You might shave a few minutes off of your cook time, okay? You'll need to check with your own, individual owner's manual on this. If you threw the manual away, look for the model number online. There are always online versions of these manuals that you can just flip through online, or you can reorder the manual yourself. Double check that I'm right there, but so far, the soft research, meaning my customers who have come back to me after this lecture in the studio, have said, you're absolutely right. On bake, it drops at 25 degrees. On roast, it does not. What does that mean? That means if I want to bake cookies on convection, I will use convection roast to guarantee my temperature. You want me to say that again? I know that this cookie wants to be baked at 350 degrees, but I also want to take advantage of my convection and shave a few minutes off the cook time. If I bake my cookies on convection 350, convection bake, what's it going to do? Drop it to 325. I don't want that. So I'm going to bake my cookies at 350 on convection roast, because by keeping it on convection roast, I keep the integrity of the temperature I have selected, not the temperature the oven is going to select. Okay? So play that back again if you need to hear that again, but there you go. Here's the short story on convection. Use it, use it, use it. My oven here is a Lang. I've had it here in the studio for a little over 15 years since we opened up in 2007. I bought it used, and it is flawless. I adore this oven, and it is convection. If you've eaten anything in this studio in the last 15 years, you probably ate something that came out of a convection oven. I use it for bread. I use it for cupcakes. I use it for cookies. I use it for everything. Why do I love it? One, because it's so much more efficient. The preheat is considerably less time because there's a fan blowing and it's getting all of that heat transferred around that box very efficiently, very quickly. Also, when I go to put my item in, it cooks very efficiently. I shave a few minutes of cook time off there. You can imagine if you're cooking 8 hours a day, 7 days a week for a living, 6 minutes a batch on something can add up. I mean, you know what I mean? Like that oven might have given me back 6 months of my life in the last 15 years. The other thing I'll say about convection is if you are interested at all in getting into the roasting concepts that I talk about in the turkey podcast, convection is your friend, because the other thing convection does, because a fan is blowing, is it creates dry air. And we're looking for a Maillard reaction. That's the caramelization and that sear and that beautiful color that we get on the outside of something that's been roasted perfectly. That fan, that air moving around, actually really helps with that. It's the driest of dry heat cooking. And so if that is something that you're interested in, it's wonderful for that purpose as well. Okay, convection, short story, use it. Be smarter than your range. If I had the options of convection bake and roast at my house, I'm pretty positive convection bake would have never been engaged a single time. I would only ever be on convection roast, because on convection roast, I choose the temperature, the oven doesn't. On convection bake, the oven chooses the temperature, okay? I think that's pretty clear on that. All right, guys, convection, engage it, see what you think. Let me know about your results. Give me a little comment down below, and certainly if you have any questions for me about it, you can reach me on my website at achefs.com, or you can put a comment down in the YouTube channel. Thanks to all my subscribers. If you're new here, welcome. I hope you'll join us for some more fun here. And next up, we'll be talking about air fryers. If you missed one or two of the oven podcasts, pop back in. None of them are long, and it's an interesting study in heat and how it works. Convection convection, short story, use it. All right, have a great day.